Hello everyone and welcome back. In the second tutorial we are especially going to look at something that I was hinting at during the first tutorial, the problem of how to do inference. And the classical way to do this is where you have a certain data set that you've received and you have a model of how it might have come about. And the thinking then is that there are these properties in the world, so I've used theta here to symbolize that have caused the data that you observe. And this kind of causal relationship is something that you have then a specific model of how this happened. But you don't know, for example, what kind of parameters actually give rise to it. And these kind of unknown variables is something that you might want to infer something about from the dataset. And the typical way of doing that then is to take the probability from your model that's now already, or at this point, no longer dependent on the data, because you already know what the data is. So your probability function is now instead dependent on the theta, so it's a likelihood function instead. And you want to try and maximize now this likelihood function in order to find a point estimate of the best parameter set that actually explains the data that you have. The way to do that classically is, a good example of how to do that classically is when you're using the normal distribution. So let's say that you're measuring the bolt fMRI activity from a specific brain area. And if you do make assumptions about this being normal or Gaussian distributed, you might want to wonder about what's the mean and variance that gave rise to this activity that you've actually measured. So you might have different kind of trials that you've been doing this experiment on, and you might have been measuring from V1 and V2. And as you then have this data set now, you want to know if there's any kind of differences in parameters that gave rise to these two different brain areas. So if you do that, you can take the probability of each one of those data points that was generated according to the model. You can then multiply the probability of those together. So this is the product of the normal distributions, each one of them. And then you want to be able to find the values then that maximizes this likelihood. So keep in mind here that this probability now isn't actually a function anymore of the data of x. It's actually now a function of the two variables that you're trying to figure out which best describe the data that you have. And as we'll of course be aware of, if you have something that is normal distributed, then actually the best fit of the two set of variables are the sample mean and sample variance. So in the exercises for now, we will learn a little bit more about the role of likelihood for doing inference. You'll try a grid search to find the values of the two parameters that have the highest, give rise to the highest likelihood. You can then play around with trying to manually fit the likelihood, as well as do it by an algorithm, and then of course compare these results to the methods that you get if you use the sample mean and the variance.